we will find the probability that two events happen in succession. That means one after the other. We're finding the probability that one thing happens and then a second thing happens. My family likes to watch Wheel of Fortune. To win $1 million, several things must happen. A contestant must land on the space with the $1 million. That contestant must also win the game. The contestant must also pick it in the final spin and solve the last puzzle. This is an example of events that must happen in succession. Each thing must happen. A and B are specific events that happen one after the other. The probability of A and B equals the probability that both A and B happen. A happens on the first event and B happens on the second event. Example 1. There are two test questions. The first is true-false. The second is multiple choice with 5 answers. What is the sample space? The sample space means to list out everything that could happen. The first question could have answers T or F, true or false. The second question could have answers A, B, C, D, or E, 5 choices. The sample space, TA, TB, all the way down. TA represents true on question 1, A on question 2. There are 10 total options here. If the correct answers are true and C, what is the chance of getting the right answer on both? 1 out of 10, because there's only one way that you mark them both right. You mark true and C, and there are 10 choices. Let A equal get number 1 right, B equals get number 2 right. What's the probability of A and B? That's the probability of getting both answers correct. The probability A is 1/2. What's the probability you get a true-false question right? 1 out of 2. The probability of B getting question 2 right is 1 out of 5, because only one right answer out of 5 total answers. 1/2 times 1/5 equals 1/10. We multiply fractions straight across. Multiply top, 1 times 1. Multiply the bottom, 2 times 5. The probability of A and B is found by multiplying the two probabilities. A and B in this case are independent. Getting question 2 right does not depend on getting question 1 right. What if the chance of B happening depends on if A happens? This is called dependent events. You pick a card from a deck of cards and do not put it back. The chance of drawing a certain card on your second draw is dependent on what was picked on the first. If you pick a card and leave it out, that means the deck looks different. Okay? If you pick one, then the deck's not the same. So it's called conditional probability. What you pick on the second go round depends on what you took out from the first. Notation for conditional probability. Probability of B/A means the probability that B happens. Assume A already has. Remember, they go alphabetically. A happens first, then B. We call this the probability of B given A. Events go in alphabetical order. A is the first event, B is the second. If we had a third, it would be C. Two events are independent if the occurrence of one does not affect the probability of the occurrence of the other. Otherwise, events are dependent. Formal multiplication rule. The probability of A and B equals probability of A times the probability that B happens given A. Multiply the probability that A happened times the probability of B. Assume that A happened. Why do we assume that A, the first thing, happened? We assume that A happens because we're finding the probability that A and B happen. What's the probability that A happens and B? So that's why we assume A happened, because we're finding the probability that it did happen and then B happens. There are 5 red, 4 yellow, and 3 green marbles in a bag. There are 12 in all. If 2 are randomly selected, what's the probability the first is red and the second is green? Assume the first is not replaced before the second is drawn. we're not picking them both at the same time. We're picking one marble and then picking a second. A is red on first, B is green on second. Note that if the first marble is not replaced, that means the bag of marbles does not look the same after you pick the first because you do not put it back. If you pick one and leave it out, you don't have the same number of marbles anymore. What is the probability that you pick a red on first and green on second? So we're finding the probability of A and B happening. So we're going to multiply the two probabilities. Multiply the probability that you draw a red on the first times the probability you draw a green on the second. Assume the first marble was red. What's the chance you pick a red? There's 5 red out of 12. We're going to multiply it by the probability that we pick a green if the first was red. Okay, if the first marble we picked was red, there are still 3 green marbles in the bag. But we left that first one out, so there are only 11 in the bag. Multiply straight across, and then reduce by finding a number that goes into both of those. You can also cross multiply. Note the second fraction is 3 out of 11 because there's still 3 green, but only 11 now. You left the first one out. There are 6 marbles in a bag. There are 3 red, 2 blue, 1 white. What is the probability that you draw a red on the first and a red on the second? Assume you replace the first marble. Okay, so we're going to multiply. We're finding the probability that we pick a red and a red. So we're going to multiply. There are 3 red out of 6 times. If you replace the first marble, what does the bag look like? The same. So if you put it back, there's 3 red out of 6 total. Multiply straight across and reduce by dividing each by 9. 9 into 9 and 9 into 36. There are 6 marbles in a bag. 3 red, 2 blue, 1 white. What is the probability? You draw a red on the first and a red on the second if you do not replace the first marble. Okay, so there are 3 red out of 6 when you pick the first one. Multiply that by. Now, if you picked the first marble and it was red and left it out, there are only 2 red marbles now and only 5 in the bag. Okay, so 2 out of 5 represents there are still 2 red ones in there, but there are only 5 now. So multiply straight across. 3 times 2 is 6. 6 times 5 is 30. And reduce by dividing each by 6. 6 goes into 6 one time. 6 goes into 30 5 times. Example 4. A pregnancy test claims that it is 99% accurate. 12 pregnant women take the test. Okay, now this is a little different what happens in real life. We know the women are pregnant. We're testing the accuracy of the test. We're not trying to see if the women are pregnant. Okay, we know the women are pregnant. What is the probability that it shows positive for one woman? The answer is 0.99 since it said it was 99% accurate. 99% accurate means if a woman is pregnant, it will show it is pregnant 99% of the time. Change 99% to a decimal by moving it 2 places to the left. Okay, same question. Part B, what's the probability it shows positive for all 12 women? The chance that it shows positive for each woman is independent of the other woman. Okay, remember, the women are pregnant, so it should show that they are pregnant. The probability that it shows positive for all women is the same as what is the chance it shows positive for woman 1 and woman 2 and woman 3 all the way to woman 12. We find the probability of and by multiplying. So we're going to multiply 0.99 times itself 12 times for the 12 women. We're multiplying because that's what we do when we're finding the probability of A and B and C and D. Using exponent notation, that's 0.99 raised to the 12th power, which equals 0.88638, and rounded. Using the same thing, what is the probability it does not show positive for at least one woman? This is the chance that the test is incorrect for at least one person. Okay, remember, we know the women are pregnant. We're testing its accuracy. Note that this is the opposite of the test being correct for all women. If at least one of the tests is wrong, this is the opposite of all tests are correct. We find opposites by subtracting from 1. Review section 5.2. The probability that it is wrong for at least one woman is found by 1 minus it was right for all women. If it's wrong for at least one, that's the opposite if they are all correct. 1 minus 0.886 equals 0.114. The 0.886 was found in part B. We're finding the opposite. Okay, what's the opposite of you make a 100 on a test? You don't make a 100. Okay, making a 100 means you get all questions right. If you don't make 100, it means you missed at least one, wrong for at least one. So that's the same thing as we're doing. What's the probability it's wrong for at least one? Is 1 minus right for everything. Example 5. My kids were both born on the same day of the week and the same exact clock time, Monday at 7:08 p.m. This is a true story. What is the chance that my second child was born on the same day and same time as the first kid? First, find the probability of being born on the same day. Okay, what's the chance that the second child was born on the same day as the first? 1 out of 7, because only one day would be the same, and there's 7 days in a week. Now find the probability of being born at the same clock time. That's 1 out of 1440. To find that, first find how many minutes there are in a 24-hour period. Okay, 7:08 is 1 minute out of 1440 minutes in a day. Okay, how do we find that? There's 24 hours in a day, times 60 minutes in an hour. 24 times 60 is 1440. So that means there are 1440 minutes in a day. Only one of those minutes would be the same as the first child. So what's the probability they both happened? What's the probability the day was the same and the time was the same? So we find and by multiplying. The day is 1 out of 7. The time is 1 out of 1440. Multiply straight across. So there's only a 1 out of 10,080 chance that my kids were both born on the same day of the week and the same time. Okay, and there's both their newborn pictures. This is something that would only happen to a statistics teacher. Example 6. Life expectancies are used to find insurance rates. The probability that a 40-year-old female will live to be 41 is 0.99855. So what's the probability that one will live to be 41? 0.99855. What is the probability that 5 of these women will live to be 41? Okay, using the same numbers as the last slide. The chance that each woman lives to be 41 is independent of the other one. So the probability that they all live is found by multiplying each of those individual ones. So multiply it times itself 5 times, which is that raised to the 5th power, which is 0.993. We're finding the probability that woman 1 lives, and number 2, and number 3. We find the probability of and by multiplying. That's why we're multiplying each one of those. Using the same information, what is the probability at least one would not live? This is the opposite of part B, where they all live. Okay, all 5 women live. What's the probability that at least one of them does not? Opposites are found by subtracting from 1. The probability at least one does not live is the opposite, that they all live. So we're going to do 1 minus 0.993, which is what we found in part B. My family likes to watch Jimmy Fallon, and I love Peyton Manning. There was an episode several years ago where Peyton and Magic Johnson played egg Russian roulette. Okay, Jimmy Fallon and his little games he likes to make up. There are a dozen eggs, which is 12, in a carton. 8 of them were hard-boiled and 4 of them were raw. Peyton and Magic take turns picking an egg and smashing it on his head. So Peyton picks, and you don't know if it's raw or hard-boiled. Okay, the goal is to not pick a raw egg. So Peyton picks, and it turns out it was a raw egg. And then Magic picks, and then it happened to be a raw egg also. What is the probability that a raw one is picked first and a raw one is picked second? Assume the first egg is not replaced. Okay, so they pick it and they smash it on their head. Obviously, they're not going to put it back in the carton. Okay, 8 hard-boiled, 4 raw. What's the probability of raw on first and raw on second? We find these by multiplying. Okay, what's the probability that the first one was raw? There were 4 raw eggs out of 12, a dozen. Now, that first raw one does not get put back, so when the second person picks, there are 3 raw eggs, but there's 11 eggs still in there. Okay, the first one got picked, so now there's only 11 left. So 3 of them are raw out of the 11 left on the second pick. Multiply straight across and reduce by dividing each by 12. And there's the URL if you would happen to like that clip, watch the clip. And if you'll notice, Jimmy says that this rarely happens. That's the end of the lesson.